Good morning. I'm Dan Conley here with Jim and Rao. I'm really excited about object capabilities and capability-based security. If you want to know what that's about in 3 minutes, there's a link there. Anyway, awesome OCAP. And I do office hours on Saturdays sometimes. So it's kind of a brainstorm. And one of the things we might look at is IBC and how we can connect our chain or agoric to various different things. Here we are. So I was thinking maybe Jim had already explained to Rao some of the big picture here, but Rao says maybe not so much. So I'll try this angle on it. Rao, did this picture cross your radar where somebody was saying, hey, they're going to do this our chain distributed exchange?
Yeah, I did see this picture, but not much conversation around it or beyond that. But it did cross one thought.
Okay.
Yeah.
So there might be 5 shards here. One of them bridge to ETH. One of them bridge to Solana and Avalanche. One of them in kind of an enterprise setting, DHL or something. One of them doing NFT stuff, and then the distributed exchange in the middle. And I said, oh, that's a credible architecture, but it's got a bunch of problems that I'm not going to discuss right now unless you really want me to. But my main point was, meanwhile, based on the multi-chain Cosmos IBC vision developed by Agoric and others, Osmosis, with a market cap of 6 billion, already does essentially all of this, except that the DEX shard is sequential. So it's got a ceiling of about 4,000 transactions per second. And the formal verification is off-chain and only covers up to IBC and not the DEX contracts themselves. So the folks that were this article that they wrote, they talked about how since our chain supports formal verification, all this stuff would be formally verified. So some detail on this, how this whole stuff is working. Oh, and another, this is a screenshot of something I didn't give a link to and I should have. Mapofzones.com. Whoa, it's busier all the time. So this is the IBC world. There's all these blockchains sending messages to each other, blah, blah, blah. And each of them is, independent sovereign blockchain, which it's somewhat similar to, what's the one that starts with P?
Polygon?
What?
No, you're not talking about Polygon, right?
No, it's from the Web3 folks. The one that has parachains. Anyway.
Yeah, Polkadot.
Polkadot, right.
Polkadot,
In Polkadot, the parachains rent space from the master in the middle, so they don't. It's not peer-to-peer in that sense. But in the Cosmos vision, it's all, like we said earlier, objects that are peers communicating to each other, right? This is how we want to organize things at all scales. All right, so that's what's going on there, and I'll go into with some more detail here. There's over 20 chains. The picture looked like that when I took the screenshot. Now it looks like this. It's more all the time. The Osmosis is one of them right here. That's the distributed exchange with IBC support. So it's got the Cosmos SDK is this software development kit for building blockchains. All these, pretty much, you could build a IBC blockchain without the Cosmos SDK, but nobody's done it yet. So the Osmosis takes the Cosmos SDK and adds distributed exchange functionality on top of it in Golang. it has a credible set of validators. So every time you stand up a blockchain, you got to get enough validators to make it credible, right? So there's all these validators. It's a bunch of business development and community building and stuff like that. And so each of these dots has a set of validators. Now the validators overlap a lot because once you've done one of them, you've already got all the tech set up to do another one. So for example, when the agoric is looking for validators, we just participate in the Cosmos community, and literally 6,000 validators applied to to be in our test net. Anyway, trading 24-hour trading volume is $28 million a day. It's probably more than that now. All the Cosmos SDK comes with on-chain governance. So for example, they have at the time they had a time of writing, they had a pending proposal to add CosmWasm smart contracts because the DEX shard itself it has kind of a fixed contract. So Agoric plans to have an IBC bridge. So one of the ways that we like to talk about smart contracts happening there is some assets from Osmosis move over to the Agoric chain. You do smart things with it, and they move back and forth. Okay, another big thing with that helps with all this stuff is a state-of-the-art multi-chain wallet called Kepler. So does this show up on your screen? Anyway, I have to find my password and stuff. So you can, there's already a wallet with lots of users that can send assets back and forth between these things over IBC. Connections to assets on several existing chains, providing billions in liquidity and actual progress on coordinated climate action. So one of these blockchains is called Regen, and their goal is to promote regenerative climate practices. And they got as far as that says the credits have already been sold to Microsoft to help them meet climate goals. In one of their cases, Regen for land stewards. The Cosmos Hub is the original Cosmos blockchain. That's their token is Atom with the market cap of 6 billion. One of these is Luna. With Terra is UST is a stable coin with 9 billion, and Luna has got a market cap of 24 billion. The crypto.com coin CRO is 13 billion. And then there's Secret Network where they have a privacy technology. Juno is another smart contract thing. Akash lets you do basically cloud stuff. You rent cloud space using blockchain technology. This is a decentralized VPN thing, etc. So those are all IBC chains, like here's Juno sending transactions today. The bridge to Ethereum is emerging. They've been working on it for a long time. There's a set of well, there was. Anyway. Yeah, there's a set of validators getting set up to good morning. Where was I? Did I lose my marbles? Christine, meet Jim and Rao. Jim is a colleague from our chain, but he was also a colleague from doing web stuff in what, 91, 2, 3?
Yeah, 91 is I found contributions from both of us. So
right. So I was talking about explaining to Rao why our chain might be interested in IBC, and I got down to here. And so the Ethereum bridge is emerging. Okay, do we have another person I should welcome?
We have two Christines.
Okay.
I think one of them is a legacy Christine that left the room. So.
Okay.
Hello.
And then Rao and Jim go way back. And then there's talk of a Solana bridge and an Avalanche bridge. So this is, this whole DEX thing in theory, and here it is in practice running, right?
And Ethereum is supports the IBC, or
no, this gravity bridge is going to reach into Ethereum, and it's not that the Ethereum folks are supporting IBC, it's that the IBC community is making a bridge to Ethereum.
awesome.
Right.
So if we bridge to Cosmos or agoric, we can talk to Ethereum.
Yeah, you can go over the gravity bridge to Ethereum.
Awesome.
Right. And so the way, go ahead.
So many people think that, that one blockchain is going to dominate the world, but the real world is going to have lots of blockchains, and
things that are not
interoperability.
blockchain, right? So let me just show a little tech here, which was, I thought surely we had it linked here. Here we go. Mark Miller was giving a talk about the Marshall types. Oh, that has moved to, yeah, it moved to Endo. So Mark Miller was talking, we have this marshalling stuff within the Agoric platform, and he was giving a talk on these types, and I thought, these types remind me of rholang. And so here's a little correspondence here. And what's the thing? GitHub, is it OCAPN? Yeah.
Yep, okay, happen.
Right. So this is one of my explorations in the OCAPN space in a way. I might have raised an issue there too, I don't remember. But the rholang folks have a protobuf representation of their programming language. And so I did a little bit of, didn't I write some code? Here we go. So this is taking the, that's decoding. I can't remember what I was doing here. I was going one way or the other. Yeah, this, okay, decode to rholang, right, yeah. So this is decoding the agoric marshalling layer into protobuf for rholang. So this would get you from agoric to rholang there. So there's some details, but okay, so we had this picture of all this glorious IBC stuff. So maybe how would our chain play along? And so to me, it takes like 3.5 pieces here. A suitable VAT TP layer, two-way reliable messaging. By the way, okay, so I'll go into this just a little bit. So Jim, what we do in Argov and stuff is we use the exploratory deploy. We say, go evaluate this bunch of code, and then we listen at one address for the result.
Right.
Right. So what I think we should do instead is just listen for acknowledgements at that result. So we're just doing message passing. I send you a message, and then at the address that we've been looking for a result, we should just look for an acknowledgement. And then we should arrange for a message passing pipe the other way. So that's what this issue is about.
Seems less convenient, isn't it?
It is a little, for if you're just doing RPC, it's less convenient. But if you want the other guy to be able to call back, if you want to be peers, you want to do peers computing at every level, right?
Right.
Yeah. Okay, so we should upgrade that way of doing things to a VAT-TP work-alike. Then we need a marshalling layer. And then we can just take the agoric cap-TP stuff and translate it to rholang. I want to do it mechanically, but if we have to do it, by hand, whatever, there's going to be certain platform specific parts that aren't suitable. And once you have those three parts, then agoric nodes and R-chain nodes can talk as peers. So now you have an R-chain node talking to an agoric node as peers, and the agoric node already knows how to talk IBC to the rest of the world. So to the rest of the world, you're an IBC node. You just take those two pieces of software next to each other running on the same machine.
Now we can basically simulate this with polling, right?
Oh yeah, part of this is polling, probably. Yeah. So that's how you. Oh, the one tricky bit that might when an IBC node sends messages, it is obliged to basically include a proof that its validator set said so. So we have to be able to take the rholang or the R-chain consensus, the records that the validators all said so, and put them in the format that IBC expects, and that could be hard. It basically can't be impossible, but it can be very hard. Anyway, so that's what I think is a 6-week project. It is these three here. That other bit with the proofs, I'm not so sure about. Before I get too deep into one particular thing, Christine, was there any topic that I told you I would put on the agenda?
I don't think so, other than you said it would be interesting to talk about. You said you're going to do a demo of some recent agoric governance stuff. And we talked about maybe talking about the presentation I had given. That's it.
Right.
I'm definitely interested in the governance side of the thing. What does that mean?
Yeah. So let me. Right, that's this one. Move this. So this is my day job workspace, and this is my VAD mode workspace. So I'm going to take some day job stuff and put it over here. So this is a demo of run protocol governance. And if we're all in the mood, I might do this live in front of you. I've never done it all the way through. But so you start a local chain. I know how to do that. That's one process, it's a one node chain. Distribute build, which is the staking token of agoric to a few addresses, it would be one. And stake most of it. Stake some of it anyway. Choose a few.
Wait.
Uh-huh.
Before we get into the description more, you have what is the problem being solved? And then you said, we believe we have identified all the pieces. That does not explain to me a problem being solved. So what's the problem being solved? So run protocol governance, I don't know what run is even. So what does that mean?
Okay, yeah, this is we, the agoric engineering team. So I mean, it's written
Okay.
in inside baseball talk. So yeah, very fair question. Okay, so what's run? That's a good question. And the answer is supposed to be here. Run is a stable local currency.
Or this is a currency pinning solution. Is that right?
Well, the demo is not. The run token is a stable coin. Yeah.
Okay. And okay, so it's a stable coin, and Let's see here, demo of run protocol governance. So given that protocol governance, is this basically the, what is the upgrade problem issue here, or what does it mean?
Yeah. So there's all these folks here that use blockchains with this Tendermint consensus thing and Cosmos SDK. In the agoric production blockchain, just has that. So all we can do is send tokens around using roughly Bitcoin technology, okay? Except that it's proof of stake instead of proof of work, right? We don't have any there's no JavaScript, there's no smart contracts, okay? And we have the build token online. So this is real assets at risk, 86 million.
So let me just see if I can restate what you just said, just so I understand.
Great.
This is the mainnet that might eventually run agoric code, and you have to actually get the upgrade problem to be resolved in order for it to start getting to that point, right? Where this thing is doing that. Right now it's being sold as being the promise of agoric's vision of those things for this type of thing, and people basically buying into that with the hope that this stuff will deploy there. And if not, it at least funds the organization that will make that type of thing possible.
Right.
Okay, good.
Right. Okay, so, and the Cosmos SDK it does include beyond just Bitcoin or Ethereum sending stuff around, it does have a built-in on-chain governance. So we recently deployed clawback vesting because some of the tokens that are given to agoric employees are vested, and if the employee leaves the organization, they get clawed back, and that wasn't part of the software. So one of our engineers did the Golang CRUD, and then we actually did a deployment and upgraded all the software and all 100 validators and all that kind of stuff. But
okay,
that's
so
all.
you need to do upgrade. So you're so the run upgrade thing is then is the issue trying to figure out the mechanism to do upgrades, or is the issue trying to decide on what types of upgrades are going to happen? Or the agreement process for the upgrades. I'm not quite sure which thing still. I'm still trying to figure it out. That's
a good question, and see if I don't answer that as I go. I'll try to explain one part of it after. So there's this whole Cosmos community that uses Tendermint and IBC at this bottom layer, and everything is written in Golang, okay? And that includes its own style of governance. It includes, all of the build holders voting to decide on things such as this. So one can do governance at this level, and basically that means sort of votes to upgrade the core software, right? And then on top of that, we have all this JavaScript stuff. And there's none of this JavaScript stuff running on mainnet yet. I'm not solving the problem of getting from no JavaScript to JavaScript. I'm solving the problem of getting from JavaScript, but no what we call the run protocol to the run protocol. Now, let me talk a little bit about what's the run protocol. So that is, there's these core institutions. Let's see if it's on the economy page. They should be. Right. So run will be used to pay for execution. Runs pegged to the US dollar by an on-chain collateral and supported by an automated market maker. Are you familiar with Uniswap, Christine?
Is Uniswap the mechanism for pegging things, or is it a particular pegging?
It's not really for stable coins. It's just it's an automated market maker, and I'll sort of talk about what that is a little bit.
I think I don't know what it is.
Right. Yeah, that's fair.
It does atomic swaps between currencies.
Well, that's part of it. But if you have USDC and I have Ether, and we want to trade, we can find each other over the counter trading, you know, and I have to trust you and you have to trust me and all that crap. Or we
So
can
it's
go
an,
to
is this an escrow service then?
sort of, I'll keep going. Or we could go to a centralized exchange where Coinbase has a whole big pile of Ether and a whole big pile of USDC. And so they'll let you trade and then they'll let me trade independently, right? Or this is an idea that Vitalik had at a conference sometime, and he said, oh, somebody should build this. And then the guy did, and then now it's worth billions of dollars and stuff. And the idea here is there are liquidity providers who put in Ether and USDC, and they get a token back, which is called, so there's a pool of these two assets paired together. And if you put in $100 worth of Ether and $100 worth of USDC, you get $200 worth of the liquidity pool token for that pair. So
who holds onto, so the US, so where does that get held? Is there an organization that actually has a bank account holding on to the USD?
nope, it's a smart contract.
Okay, yeah, but somebody's saying that what happened? So if I am going to be putting in some Ether and some USDC, what's ensuring that I'm if I've got my, you know, pile of cash on my desk, or I've got something in my, you know, JP Morgan Chase account, what do I do to be able to get that part into the smart contract just to really stake it?
Oh, well, you have to go buy some USDC and buy some ETH.
Oh, okay, wait. USDC is a USD stablecoin.
Correct.
Okay, all right. That was the part that I was not clear on. I thought USDC just literally meant US dollar like coin. I thought it was just like the C. See, as you can see, I'm not as deeply versed in a whole bunch of
Sure. This is great. Because my office hours are about OCAPS, not about blockchains. So you don't have to have a blockchain license to get in the door. But so if we had, like, here's one that's where maybe it would have been less confusing because neither of the tokens is USD, is a stable coin, right? So here's folks that have Bitcoin and they brought the Bitcoin over to Ethereum, at which point it's called wrapped Bitcoin, WBTC. And then
sorry, I have a bunch of questions because I'm trying to understand this space as you go. How does the wrapped Bitcoin work? Does it get assigned to, you know, I could imagine some sort of, you know, like building a shared, some sort of, I can't think of the name of it, but, you know, some very smart crypto where you and I are both working on building a key that neither of us independently controls. Is that effectively what's happening? And
yeah, I'm going to skip that one. Yes, there's some crypto magic and somebody figured it out and it's called hash time lock contracts and blah, 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 whatever. Okay, magically.
Cool. Okay, black box.
Yeah. Magically, there's a thing called wrapped Bitcoin where you can trade one Bitcoin for one wrapped Bitcoin and back and forth.
And there's an escrow process controlled by a contract to ensure that the wrapped Bitcoin is in escrow on the Bitcoin network.
Right. Okay. So this is called an automated market maker, and the reason that it's automated is just there's these three kinds of parties. Well, two kinds of parties. There's the traders. If I want to, trade WBTC for Ethereum, I go in and I put in Ethereum and I can get out Bitcoin at whatever the price is. And the way the price is maintained is I'm gonna not go into. It's pretty interesting. And then there's the liquidity providers, and the liquidity providers get a cut of every trade, and that's why you would do such a thing, because they actually lose when the price goes up and down and stuff. Which anytime somebody trades one way or the other, the price goes up or down a little bit. So if there's a big swing, then the liquidity providers are at risk. And anyway, so you can see for each pool, they sort of extrapolate out. No, they don't anymore. They used to give a annual percentage rate of. Oh, they have different. It used to all be 0.3% was the cut that the liquidity provides. Anyway, there's this thing called an automated market maker, and it means that given sufficient liquidity, you can always trade X for Y, whatever X and Y are. Okay. And it means that suppose that the arbitrageurs, whoever they are, suppose that, I don't know, there was a big move in the marketplace and on all the centralized exchanges, the price of Tether, or the price of wrapped Bitcoin went from 39,000 to 35,000. Well, those folks could, anytime there's a difference in the prices, the arbitrageurs can win, right? So this thing will cause its price, you know, the price here will catch up with whatever the dominant price is in the marketplace reasonably quickly. And so through that mechanism, USDC stays very close to $1. And that's the only thing holding USDC to close to $1 here. And
Got
so through the same mechanism, the run is expected to stay close to $1. Okay, so the AMM is automated market maker inside of Agoric is part of the run protocol. And the other one is this vault system, which is like where you can if you have a bunch of Atom or ETH or whatever, ETH is kind of, there's some asterisks there, but if you have Atom or Build or whatever, you can put it in a vault and take out run. You can get a loan against your crypto and go use the run for whatever.
So
Okay.
Dan, are you saying that run basically mimics the Uniswap model of keeping values in sync? Is that?
So sort of. Uniswap doesn't directly provide stablecoin features, so I might have overspoke there. It's actually it's the vault system that does it more. I don't know if I can explain this stuff very well, but so Maker and DAI, are you familiar with those two tokens?
Mm-hmm.
So you can, Maker is the governance token, and you can lock up Maker, I think, or you lock up ETH or something. Originally you locked up ETH and you got DAI, and the Maker token was used to make sure that the DAI that stayed close to $1. Like if the price went up, they would do something to make it go, make it cheap, make the incentivize the arbitrageurs to make it go down, and vice versa. And we had the same mechanism, and I don't completely understand it, but it's credit default swaps is the traditional finance mechanism.
Mm-hmm.
So we have a vault system that's like MakerDAO, and we have the AMM that's like Uniswap, and maybe one or two other contracts, and those three together are the run protocol. Okay, so again, our tech stack, there's
Okay, let's see if I can start to summarize now with everything you just said. So the governance thing that becomes emergent from everything you've just described is that since it's coordinating those three things, at least the coordination between those three different things is going to be a major part of the governance here, and also basically any kind of code upgrades that's required and protocol upgrades between those various pieces. Is that right?
Yeah.
Okay. All right. I'm sorry. I'm being very slow. I'm just trying to make sure I understand.
Great. This is great. This is,
I get the sense that I'm the most cryptocurrency newbie person in the room, because I just spend all my time thinking about OCAPS, and I just don't spend all my time thinking about this stuff, basically.
But your questions increase the value of the recording because it means it's useful to a wider audience, right?
Absolutely. Yeah.
Yeah.
Yes.
Okay.
I'm learning a lot from your questions too, Christy. So keep asking.
Good. Yeah. The comment I would make about a stable coin is that if you sell it whenever the price is too high, you're selling high, you're making money, and if you buy it when it's low, you're buying low, and you're continually making money by keeping the coin stable.
Right. Okay, so somehow that I'm going to assume for the purpose of this demonstration, we're going to get from Cosmos, everything's Golang, to JavaScript and Zoe on the platform. And then once JavaScript and Zoe are on the platform, we're going to use JavaScript and Zoe and Cosmos governance to vote to start the automated market maker and the vault system. Now let me read this description and see if it makes any sense to you. In fact, well, no, I'll read the description before I start doing it. Start a local chain, and that thing is going to have both the Cosmos Golang stuff and the JavaScript and Zoe stuff. Then we'll have one client with some build. That build holder will stake some of their build. Choose a few addresses. This is going to be one. For the economic committee members and a chair/secretary, it'll all be me. The economic committee is the body that can change the interest rate on the vault system, for example. There's a few other parameters they can change, but we don't want to have the whole world vote on every single little tiny tweak to the system. So the committee of the whole, the build holders, elects a committee to do the little tweaks, day to day in the system.
It's the reason why most democracies end up being democratically elected republics, is that the people just don't have time to get expertise in each individual thing and get into the details.
Right. Okay. Then we will make a Cosmos level governance proposal to start the run protocol and seat the committee. We'll vote on that Cosmos level protocol using our staked build. When the vote carries, the protocol should start, and invitation should go out to the committee members and the chair. We should get some run using a thing that I don't have integrated yet. Actually, we should change the interest rate. We'll change the interest rate. That is, the chair puts the question, the committee members vote, the question carries, and we confirm in the user interface that the interest rate has changed. Or we get another, we do something else where we can see the interest rate changing. Does the description make sense now, Christine?
Yes. Yep.
Okay. All right. So I'm going to bring another widget over from here. Oh, that's kind of relevant. That's less relevant. And this is put this on all our things. Okay. So I had done the first step of this last night, but so that you can see there's nothing on my sleeve. I'll do it again because, all right. This starts the blockchain. Believe me.
Believe. So, disbelief suspended. How about that?
Right. Lots of software is running. Launching swing set kernel. You know what swing set is, right?
I know what swing set is for sure. Yeah.
Okay. So it's launching swing set connected to all the Golang stuff that allows it to
Okay,
do.
wait. Now I have a question, because you just had told me, for one thing, I'm looking at the fact that you've got a 0.0.0.0 plus port. Is that open to everybody else on your local network? And is it also a opening for a confused deputy? Prometheus, what does that do?
That's, how many somethings per second. It's a metrics widget.
Okay, it doesn't matter too much if that's exposed, other than somebody maybe getting some information about what you're doing.
Right.
Okay.
Yeah.
All right. So sorry. Every time ever since the Guile vulnerability that I think I told you about that I was involved in, did I tell you about that? It's my favorite. This is my favorite. Sorry. Brief aside, it's my favorite confused deputy story. It's the one that allowed me to understand confused deputies. Is that it was a
Wait, can you help me find it first?
Yeah. Actually, let me pull up the link. Guile confused. Yeah, here it is. I'm going to link it right in the chat, and then you can open it in your browser. So
Roger.
just put it in there.
Okay, now
You know.
chat. This one?
Yes.
All
So
right,
here's what it
talk
was.
us through it.
Okay, so there is a so Guile had this thing. A number of languages do this, where it's like, oh, okay, well, you want to do local development, that's fine. So if you can imagine, let's say you're doing something like a game engine, right? So you've got a game engine, you've got this running process. You start up the process. There's already a window running and everything like that. So you're not just opening a REPL. There's already some application running. So you want to add a development environment so you can start hacking on the thing while it's running, right? So there was this nice feature added where you could open up a REPL from from the program, and like, you know, you have some code that's, you know, the program is intentionally set up where it says, sure, I'll launch this this localhost +4 thing, or at the REPL, even when you launch any Guile program, you could pass in --listen and a port number, and it would do this. So
Right.
it open on localhost +4. This is perfectly safe, right? Because it's only people on the local machine, right? Well, okay, this is where Mark Stiegler's quote, perimeter security is more like eggshell security. It seems pretty tough when you tap on it, but poke any hole through and you can suck out the whole yolk, right? This is from the Ian a Walnut thing. Yeah. Anyway, yeah, it's a great quote. That's the one. He actually, my version is a shorthand version, but if you look for egg, yeah, defense in depth versus eggshell security. So this really helped me understand what was going on. But this happened after we had uncovered the thing. So what I realized was that, oh shit, you know, you can see my dead names on there. But I realized, oh shit, if you somebody had just made a blog post about that was calling attacking developers' databases. And it was basically like, oh, look, you can direct somebody, you could use a DNS rebinding attack. You'd send somebody to some website. Then if you controlled their DNS provider, or, you know, could man in the middle of that, because usually it's not secured or whatever, you know, anybody who has access to controlling the DNS thing could actually rebind, shockingly, localhost to anything they wanted. And then, or they could rebind other domains to be localhost. Like to be 1.0. And so your browser, having access to both of these things, becomes a confused deputy, as usual, as browsers often are. And so all you had to do was direct somebody to some page that loaded some JavaScript that would do a HTTP post to localhost. Turns out, actually, this is even worse. You didn't even need, in most browsers, to do the DNS rebinding attack. So if you do an HTTP post to that, and in Guile's thing, it had a line delimited protocol. So it would read the first HTTP header and it would say, oh, I don't know what that is. And it would just, you know, print an exception. Read the next HTTP header, it says, I don't know what this is. Then it would get down to the HTTP post body. You could put any scheme expression you wanted in there, and it would execute it as your user. And, you know, you could do rm-rf/ and it would do it, right? So that was so there was some hackery put in for this, and to detect the HTTP posts were done, but of course that only blocks the browser based version things. And so the beautiful thing about this is that the classic argument that that was made about confused deputies about, like, you know, well, neither application is doing anything wrong. That was actually made by people from both sides. In this case, well, Guile wasn't doing anything wrong, and the browser wasn't doing anything wrong. And that's exactly right, right? When you have an ambient authority problem, when you take a perimeter security approach, two programs that are behaving correctly end up having the problem combined, right? So it's an attack on ambient authority, right? So anyway, that's my favorite story of that. So when I saw 0.0.0 and then a port, that made me think, oh, like what interesting things could I do some sort of attack to try to get out of this? But if it's just a metrics, the answer would probably be I can get metrics about what type of thing you're doing on your computer.
Yeah, so this does carry an OPSEC risk, and it's traditionally managed with firewalls and crap and that. So, but yeah, in our, you know, in this configuration, yes, it's the default.
Okay, cool. So anyway, sorry for that aside, but you said that this was a largely usually OCAP room, so I had to throw in the
it was very much in order.
extra thing.
All right.
Okay.
Yeah, thank you, thank you, thank you.
All right. So we started a local chain. And okay, now we're going to do the distribute build by doing the second step here. We're going to run a client. I've already got myself confused too many. Okay, so I need another window. Yeah. So this is doing blockchain, you know, what's it doing now? It's saying, please provision me a C list and stuff, you know, please give me a window. Here's my, I have a private key, you know, and here's my public key, and please give me a C list corresponding to this public key.
So basically, this is part of Run is part of the story of moving from the agoric blockchain, currently not actually running like Swing Set and the other tooling yet, and moving towards a point where that stuff has started to being integrated into it. Is that right?
No, this particular issue assumes that the JavaScript is running.
Okay, it assumes that it's running on your machine or on the blockchain or what?
Yeah, whatever blockchain we're talking about. In this case, it's a local blockchain.
Oh, okay. So this is not specific to the agoric's blockchain. This is more general. Is that right?
No, this is, sorry, this is the agoric blockchain. But to get from here,
but it's not mainnet. It's a local instance of it.
Right.
Okay.
Right. It's also DevNet, by the way. So this is our mainnet, which has real assets but no JavaScript. Okay. And then we have DevNet, which has fake assets but JavaScript.
Okay.
All right. Cool. But there's no run protocol here. There's no AMM. There's no vault system.
What by the way, what are you doing to prevent people from treating your DevNet as if there are assets on it? Because as we know, with every massively multiplayer online RPG, people start treating things as money that you don't want them to. Are you resetting it every now and then or something?
Yes, and in fact, this happened. Our previous DevNet went down, and we're like, what the heck? It turned out that somebody, well, we have a faucet. You can go to a Discord thing and just say, give me, you know, free money, right? And you can do it once per address. You're supposed to be able to do it once per address. We had turned that off because of some, you know, temp for Bob, right? And so somebody said, give me 10, give me 10, give me 10, give me 10, and they got control. And then they got bored and wander off. They stopped voting, so the whole chain halted.
Wow, it's amazing. I love this story.
Yeah,
my favorite. This is my favorite blockchain story. All right, okay, continue.
Right. So we're going from this DevNet situation of we have JavaScript, but we have no automated market maker, to we're going to have the automated market maker. That's the particular 4348 problem. All right. And then, so we distributed build to a few addresses. Okay, now I got to stake some. Where are my cookie crumbs for staking? Oh, crap. Deer in the headlights. Is it already staked? Okay. I guess I don't have to do the staking part somehow. I have to, you know, one of those make lines must have done that or something. All right. Or maybe it just comes that way. I will fire up our client, by the way, the web interface to it. So here's this thing going. And then I'm going to make another shell. Then I have to make sure, yes, okay, right version of Node packages.
So I'm a little bit lost as in terms of what's happening now. You're doing a bunch of things. What should I be expecting? You are doing a bunch of things that we are going to end up moving towards stepwise. Like when you finish these set of things that you're doing, what will I be seeing? That way it'll help me be able to understand what's coming as you're moving along.
You'll be able to see that the automated market maker is running.
Well, what is the automated market maker? Sorry, you gotta define all these things. I'm not an insider to this.
This is an automated market maker.
Okay, so it is the swap
Yes.
in tooling. All right, okay,
Yes.
that explains it. Got it.
Good question. All right. Okay, I'm gonna just, oops, wrong thing. Agoric start, REPL, reset. No, don't start, sorry. Agoric open, REPL. Oops. So in this case, note the, not just a port number, right? So no confused deputies here. It chopped the large random number off for user interface purposes, but it did, you did have to give that in order to get here. So here I am, the client. I have 13 build and 49 run. I had 50 run and it cost me 20 cents to get to where I am right now. And you can, okay, so this is.
Wait, can I actually call that out? The user interface reason that I am guessing you did that for is actually to prevent shoulder surfing attacks. Is that right? Because browsers are not designed for capability URLs in general.
Oh, right. You mean the reason it chopped it off up here? Yes.
Yes. Yep.
Right.
Okay.
Right. Okay. And then, so I've got
To
a
build browser
JavaScript.
from scratch, we would encapsulate the shit.
Right.
Sorry.
Well, we'd
Continue.
want a pet name up here instead of a URL. But anyway. All right. So this is JavaScript, but if I do, if I ask for the date, it's a deterministic version of JavaScript. So the date thing is neutered. And if I call math.random, it's going to say, what the heck is that? All right. Otherwise, it's JavaScript. And then each client gets a thing called home, which actually has two parts, but we'll do object keys home. So home is, I forget what HTTP is, but there's a local time service. I forget what that is. Scratch is a key value, store. Okay, agoric names is, so some of this stuff is, so these are widgets on my client side. They're just, on my machine. Now my machine is both machines because I'm also running the blockchain, but so home is kind of made up of local and agoric, and agoric is the objects that are actually on the blockchain. So there's a name service on the blockchain. There's a thing, there's my bank, that's my personal bank. There's a thing called a board. There's a chain timer service. So we can do things like home.chain timer service get current time. Now it's doing a request to the blockchain and it comes back. Okay. So, and IVC and blah, 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 blah. Okay. And now if I could do, are you following so far?
Yes.
Okay. So in this home.agoric names in particular, here, let's do this. Agoric names equals. Yeah. All right. This isn't the only way we'll be able to detect that the AMM is running, but it's one of them. Okay, so the name service has this reserve function, and it means until somebody has filled in this spot in the name service, don't resolve the promise, but it's not going to give a 404. It's not going to say, what the heck is that? It's just going to give you back a promise that if anybody ever fills in this name, the party that has the rights to fill in the name fills in the name, then our promise will resolve. Okay.
So I'm gonna throw in something. You mentioned pet names previously. I am pleased to see the name hub here. So I'm assuming that with whatever you're planning on doing, you're planning on taking the approach that this is effectively there's no specific central naming hub. Everybody has the privilege of being able to put up a naming hub. This is just
Right.
one recommended naming hub, right? That's a pet name type approach. That edge
Yep.
names are where you basically don't have a DNS, right? You can import DNS, but there can be many things that act like DNS.
Right. In particular, I'm sovereign. You know, when I made up a key pair, I get a name and bin for that. The name and bin is the right capability for the, and then names by address is looking up everybody else's name hub by their blockchain address. Read access to everything.
Okay, this is interesting. We should also compare later the stuff that Jessica did recently for her pet name.
Definitely.
grant.
In fact, can we visit that right now? Can you help me find it?
Oh, just go to sprightlyproject.org. In fact, I could even do a live demo of it. But yeah, let's look at the blog post.
I just want to, yeah.
Scroll down to all the way past all the Dungeons and Dragons set of characters there, all the way to the blog area. There you go. Pet name systems. It's not the digital cache one, but the pet name systems one. Okay, so
I just want to bookmark it for, and I'll be able to watch something, or is it just reading?
It's just reading. It's an ugly as sin user interface, although it does have a cute avatar generator I created somewhat. But the more important thing there, it's not the final user interface we want, but it does demonstrate some interesting properties. So it's kind of an intermediate post explaining kind of some of the status of the pet name stuff that's happening.
Okay, very cool. Hope to get back to that. All right. I'm going to put it there so I can. All right. All right. So we have a pending promise for the AMM, right? For the automated market maker. All right. Where were we on? Okay. So now we got to make a governance proposal to start the run protocol and seat the committee. So I think I have this proposal ready. We have this permit system that I guess I'm not going to go into because it turns out to not integrate nicely at this point. But so here is roughly well, here's the permit system in action. Oh, in fact, let me show you something kind of cool. Let's go up here. Go to packages, VATs. Oh, this is, I think I already have them built. So in a capability system, you got to have some initial conditions. So these are the sort of initial conditions. These are the functions that build the initial conditions, and so they all kind of run concurrently, and it's orchestrated using promises. And so this is what happens at Bootstrap, and we get things like Zoe in the run protocol and issuer, and the fee mint access is the license to print money. So if you send that to a contract, it can print run. There's the initial supply of run, so all this stuff. But there's no vault system, and there's no automated market maker here, right?
Mm-hmm.
So that's what's got the blockchain's got right now. And then our proposal is to make the world look like this. So it has the automated market maker governor, which is subject to the governance committee. And there's the vault factories. Zoe is still there. Zoe has a bunch of.
Somebody put together this design manually, I'm guessing, right?
Nope.
Okay, is this
Well,
auto generated?
The figure is auto generated from the code.
Interesting. Okay, so this is something that I've been I've been talking about. Also, I wonder when this happened, because this is something I was a number of months back. I was I guess about 6 months ago. I was telling Mark about this idea I had for an auto Granovetter diagram maker that extracted from the running object capability graph. So I was wondering whether or not that's what was happening here.
Ah, that's a different widget. I do have that widget, but that's not. But this one, the code includes this big hunk of data, and that diagram.
Okay, so it is based off of data. It's not based off of a running OCAP system.
Right.
But I would like to talk about that if you have something, or if you want to hear how I was thinking of doing it.
Right. So you can mentally bookmark that one.
I'm introducing a ton of continuations into a bucket
Yep.
here for us.
Right. Reasons to do more Saturdays, or whenever we meet with Jar or whatever, Jonathan, whatever. Okay. So our proposal is to share the economy bundles. That basically is to make some code available to other steps here. Start the economic committee. That one's important. Set up the automated market maker, and that's going to need the chain timer service and Zoe, and it's going to need the special access to the economic committee. It's going to need the creator facet. It's going to produce the AMM stuff, the creator facet, and then also an instance, which is these are kind of public. This is only available inside this Bootstrap world. It needs read access. It needs to consume the run issuer. It's going to consume the installation of the contract governor code. It's going to produce an installation of the AMM. Anyway, I hope you're sort of getting the idea. Consume and produce are, showed up as arrows in the code, and then
So wait, why is this done as data? I'm confused. So what is the structure doing? Is this structure just to explain it, to create a visual diagram for the user, or is this being used in something that's specific? I don't understand this.
So this is the code where it's used well. In the other context, it's used less well. But what happens is
this almost something that's like almost kind of evaled almost? It's like as if this was like a giant quoted expression and it's just kind of being evaled based off of like internal mappings of these things, or what?
No, let me try explaining it this way. So this is all the power in the world. Right?
Sure.
Okay. And it's kind of exposed as a bunch of JavaScript objects that have properties that have properties that have whatever. Okay. And then we have a bunch of behaviors, functions, and then we have this manifest that says, for this behavior, I permit it these powers. Okay. And then, so we go through all those, and for each of the behaviors, we take the behavior name and we look up the permit for that name, and we extract just the powers that it's allowed to access. And then we call the behavior with just the powers that it's allowed to access. And part of the reason
we're setting up facets for each thing and then doing basically an apply against it.
Right. And a big reason for doing that is so that you can make diagrams, so that you can have declarative, you can do static analysis easier than running the code. I can make sure that everything is produced.
Okay, I think I have a way to be able to I think I have a way that I would really like to discuss where we can do this, where you don't have to do it in the opposite direction. That is all generated for you from the code using the same mechanism we want to use for serialization and upgrade. And then you can do the static analysis on it from there.
Oh yeah, that'd be cool. Okay. Meanwhile, okay. So here is our proposal in the Cosmos sense is going to consist of a hunk of JavaScript and a hunk of JSON. And this is the JavaScript, and we're going to run the JavaScript, and it's going to send all those powers, or at least all the powers that we've permitted, and we've permitted everything. But then inside here, we sort of recur, and this applies the permit logic again. Anyway, so we're going to run all this stuff up here. All right. No, I meant to switch windows, not switch this thing. So what planet am I on? This one. Okay, so right. Let's do these separately. Hello? Oh, wrong window. So that just submitted a Cosmos level transaction to put a governance proposal on the chain, and it used, like I said, our permit and our governance code, and that's actually the wrong title because it's not evaluating that code; it's evaluating this code. Ooh, no, I did that wrong. Oh crap. Okay, I need to. So that one actually is doing something trivial. Might as well. Let's finish the trivial one because it might be illustrative. Scenario 2 vote. Oh, the before action I'll show you, which is, so before is those objects, in particular object.keys, agoric. I guess we had that above. And then after, oh boy, I gotta be careful because agd query go. I have 2 minutes to vote. Vote end time is 16:10 and 5 seconds. Our blockchain time, 16:10, and so it should have happened right in there. So let's go over here and look at our, now we have you are governed. So agoric.you are governed. So this what we call the big hammer governance has the ability to just shove something in everybody's home. That just shoved my address in.
This is a little bit weird. This is weird. This feels like what do you call it? The JavaScript thing that always made me unsettled with the object model, where you could insert things into, you could monkey patch things into what's the name of the object model that JavaScript comes with by default that everybody hates?
Oh, prototype. Yeah, this doesn't really have
model.
anything prototype. This is a proxy. And so
oh, okay, all right. That's less scary. I was just weird, like, wait, where did this thing come from? All right, okay, got it.
All right. So that was, you just watched the governance mechanism happen. Now, if I go back here and the eval code, let's test, and the eval permit equals run protocol, test run protocol permit.json. And we are now at vote proposal 2. And I'm going to go ahead and do the vote step while we're at it, because you've already seen them happen separately, I think. Oh, and I didn't turn on the kind of logging that would let us see all the machinations happen. You know, this thing's firing up and this thing's firing up and this thing's firing up. But we can watch our unresolved promise. Wait, there. Our unresolved promise for the AMM. And it should resolve in 40 seconds or so. What was this? Oh, that's not. This is my client. That was me doing a lookup, and this is me doing a get update since. Oh, yeah, get update since is the notifier stuff that this thing is subject to a notifier, and so the appearance of this thing got delivered to us in a notifier, and then whenever since we got an update, we immediately go back and say, when's the next update going to be? So this is now a pending promise for the next update. Is there anything else interesting to look at while it does this stuff? The other thing is, if I got this wrong, I don't have the logging on that will show me error messages. Still unresolved. I'm starting to get nervous. I have too many tabs open, but what I'd like to do is at the end, I have this thing that grabs all the tabs and then I share them. So before I dismiss any tabs, I got to put them someplace else. Oh, I know I could put them. I could put them. Message is too long. Boring. Okay, so we have a choice here. We can try this again with better debugging. We can adjourn, or we can pick another topic.
Why don't you walk us through the simulated next steps of what would happen by just telling us each steps that are expected to occur next, and just as just talk us through the next couple steps.
Yeah, in fact, I can show you the resulting state easier. It won't be connected to all the same things that this is connected to. But okay, so this promise would resolve and then some other stuff would happen. So if I go to so this is the DApp over here saying, if you want to keep going, you got to approve me in your wallet. So I'm going to say, yeah, I'm going to approve that. And by the way, I gave it a pet name when I approved it. And so now it's trying to go and talk to the AMM contract, or the running AMM instance, and there isn't one. So that's going to spin forever, just like this promise is going to spin forever because something's wrong. Okay, but let us kill that one, which is going to cause too many windows. cause this to go red. We're not connected to, we're not connected anymore. Welcome, Bill. All right. And then I'm going to kill my blockchain. And I'm going to run a different kind. I'm going to do just JavaScript stuff with no Golang stuff. All simulated, all the blockchain stuff will just be simulated with JavaScript. And for that, to start dev reset with verbose. And I'm going to put that in a log. And then, oh, Frabblezaddle. Okay, to you have to agoric init first and be in a dap directory. So agoric in boot, right? This one is as good as any. I could make a new one if okay. Agoric start reset minus v2 greater than dev.log 2 greater than 1 ampersand less dev.log. Oh, that's the diagnostic is crap, but that's because I got the wrong version. Right. Okay, so this is starting a fake chain. And so we're going to start swing set over again. So this guy is dead, but he'll wake up soon because this is going to start a client and a server.
I'm a little bit lost on what's happening between where you were in the demo and where we're heading now.
I'm going to show you a version of Bootstrap where just everything starts up. The AMM starts up, and there's no stop for a governance vote in the middle.
Okay.
I think I'm going to anyway. I don't remember this taking this long. Oh, there's lots of stuff happening. Launching swing set kernel. All right, so now it's bundling up a bunch of JavaScript stuff. We have a ticket to cache that stuff that nobody has time for. But it's really annoying when you change some code and then you run a thing again and the behavior of the system doesn't change. And then you realize that that's because you have some bundled code that you haven't updated. So we err on the side of grabbing the fresh code. So there's a 40-second pause time or something. We should see a bunch of bootstrapping this, bootstrapping that stuff shortly. If I remember right. There we go. Yeah. This is the promise orchestration. Okay, and then yeah, these are all the bits and bobs of the bootstrap, getting set up and promises settling and all the stuff that we needed in order to work out the bugs in the code as we were building it. So now our client, I have to, okay. This guy is happy. Okay, but there's still some stuff loading. We can do our 1+1 stuff, obviously. AMM settled, remaining vault factory, get run, blah, 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 blah. But I can't talk to them yet because until a lot of stuff is ready. Wait a minute, maybe I can. Oh yeah, home.agoric names is not there yet. There's some stuff that's batched that we've only recently fixed into, making it stream a little bit at a time.
You mentioned the possibility of getting into some rholang.
Oh yeah,
there's
yeah.
a pause, so we can do some of that.
Yeah, Christine, I'm going to give you a crash course in rholang.
Cool. And I see already some very visual programming looking stuff.
Yeah,
This should be fun.
yeah. All right, I don't need to go into presentation mode. All right, we had this governance thing. Several of the people here helped me work on it. When you vote, you do click, click, click on like forms normally. And while you're clicking, it's generating this GORP of rholang, okay? My what? Okay, what exactly am I signing? All right, so there's some stuff at the top. I'm gonna skip over this a little bit. It corresponds roughly. Okay, there's some like writing checks for each candidate in parallel, yay, count the tallies, whatever. Okay, crash course, rholang, row calculus building blocks. There are these calculus building blocks. There is nil. There is 4 with 3 blanks in it. There's send with 2 blanks in it. There is star with 1 blank in it. There's parallel with 2 blanks in it. And there's at with 1 blank in it. Processes in parallel. So that's the same stuff as on the previous slide. We scooch it over. We can take nil and we can put it in parallel with nil. Not very exciting. We can take nil and put it in parallel with nil in parallel with, oops, we haven't filled that in yet. All right. So then it turns out there's 2 kinds of blocks that should have had 2 kinds of colors, but I wasn't that smart. Nil is a process. At nil is a name. Star at nil is a process. At star nil is a name. So at is a quoting operator. Star is an evaluation operator.
Okay. Yep.
All right. So now that I've got nil at star, I can plug that in this parallel because this is a process, and the parallel thing puts 2 processes in parallel. And now that I've got a process, I can quote it, and so now I've got at parallel blah, 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 right? And I can go, back and forth here as many times as we like. All right. The magic happens when now we're going to look at send. All right, so send has got 3 blanks, and they're all, no, let's see. It takes a name here. Oh, sorry, 2 blanks. Send is this 3rd one here. You send a process to a name. So this stuff that we played with earlier, we put some Tinker toys together to get a process, and at nil is the simplest name. All right, so that's a send. All right, now a receive has got 2 names and a process. We haven't filled it all the way in here, but we're going to receive from the name at nil something, and then we're going to whatever it is we receive, we're going to plug it in down here, and that's the process that we result in. All right, so if you have a send to at nil and a receive from at nil, you get communication. And the result is we sent this thing.
Wait. Hold on. Before you continue, the send from and receive to. So at this point, that's becoming an address.
Yeah,
right?
names
So
are
okay.
addresses. Yes.
All right. Okay, so that's an address for the process, and so this is okay. All right, I got it.
Gotcha. All right. So we send this process to this name, and we receive it at that name. So then we plug this process in down where that blank is. And this is the result of the communication. These 2 were in parallel. Okay.
And there's the rule is effectively anybody who can construct that name can send or receive messages. Is that right?
Yep.
Okay.
Right. Okay. Right. So we had formation rules up to here, and this is the only elimination rule. Okay.
Wait, hold on. I want to see if I can understand what this elimination rule is. So, because this one is piping between these two, so this one is creating parallel process of nil, and then one process that also has nil. And I'm just trying to see. Yeah. Okay. I think I see that. All right.
Okay.
Cool.
All right. So that was the crash course at the row calculus level. There are names and there are processes. There are 5 ways to make processes: nil, receive, send, dereference, and parallel. There's one way to make names, quote. I'm going to go past row calculus into a tiny bit of rholang. So rholang is row calculus. So all of these building block things have ASCII versions. Fair enough?
Yes. Yeah, I'm with you.
Okay. Now there's a thing in rholang, which is new X in P. So row calculus provides an infinity of names, right? You can take those building blocks and just keep building and building, and we have as many as there are integers, right?
Yep. You're basically making giant tally marks of names.
Yes, right. So you can always choose one that does not occur in any other rholang expression. We just posit that, and and you've chosen one that's unforgeable because it's like choosing a large random number, but it's even larger than that.
Wait, wouldn't that make it unguessable, not unforgeable?
It would if you were, let's see.
Like that's a standard argument about sturdy refs, is that they're not unforgeable, they're unguessable. Live refs are unforgeable.
Okay,
Sturdy refs are unguessable.
rholang has static scoping. So when you use this new X in P, it's unforgeable. There isn't actually any big pile of syntax behind it. It's just new X.
Okay. Oh, okay. All right. I see. Okay.
Yeah, it's just static scoping. In fact, the way it's implemented on the blockchain is unguessable, but anyway. And so new X in P just means let X stand for that name in P. And then there's some other things that are processes as well. 1, 2, 3, and ABC are processes, true, false. There's URLs, URIs.
Well, let me put in another thing. You can take the C-list approach, where you have the language compiler effectively every time you do new X or whatever, actually construct new names for you all the time, so that it could even do it incrementally, right? Where that if you've got a C-list type approach, it doesn't just have to do creating something very large. It could just end up growing that, but just not give the user access to be able to increment that if you're using your compiler environment in that type of way.
Okay, none of this has to do with anything about compilers or anything. This is the language. Okay.
Oh, okay. All right.
I'm telling you.
Okay. All right. Cool.
There is a thing, new X in P. It creates non-forgeable names, just like static scoping in Scheme, right?
Okay. Cool.
Okay. And then there's other kinds of processes that act a lot like nil. 1, 2, and 3. All the integers and strings and stuff act like nil. In the earlier stuff. And there's also a literal form of URIs. There's structured processes, tuples, lists, maps, and sets. And then there's a little bit of syntactic sugar, and there's polyotic send receive, which is a small, anyway, and then there's match. And then there's more, there's maybe a couple other things, but that was pretty much it. That's pretty much rholang. And then I got back to the voting thing and explained how the voting thing actually works. That was the crash course. Let's see how our patient is doing. Unless you have immediate thoughts on that.
No, it makes sense so far. Now yeah, it makes sense. And
Cool.
actually, I guess if that was the entirety of it, then it makes sense.
That was the entirety of it. Yeah,
Yeah, that's pretty much the whole language. It's not terribly intricate, and that's both its strength and its weakness.
Yeah, so this
Yeah,
is
I
row
was-
calculus, which is really the core, which is kind of the equivalent of lambda calculus, and this, front side of a t-shirt, right?
Yeah, I was thinking this look when we were at this stage, I was like, this feels like when you just write out lambda calculus like by hand with just like literally stringing a bunch of lambdas together.
Yep.
And this is and then I guess that's actually exactly it, right? So the lang is to make something a human being
Right.
can use, as opposed to just writing lambda x dot x, lambda lambda
Right.
lambda lambda lambda.
And the critical difference between this and lambda calculus is the parallel widget.
Well, wait. The general argument is that the base lambda calculus doesn't have any distinction between like when it gets reified in something like scheme, we usually have make a distinction between we end up doing things sequentially, but when things are in the lambda calculus itself, it usually does not have a specific application or evaluation order. Isn't that right?
Yes and no. That's true. It doesn't have an evaluation order, but I don't have time to explain how that makes it. How I mean, there's the whole Robin Milner pi calculus, and there's a whole body of work stacked on top of it, right? That's just
Right.
different from lambda calculus.
Okay, cool.
So, it means that two programs in a network two machines in a network look a lot like two programs in a program, two parts of a program in a program. So, so it's easier to look at some things that way. All right.
Cool.
Now our patient is back to life. Oh, here's our patient. Yeah. Oh, unresolved problem. Yay. Okay. Instance handle. So now, if we look at this guy and we start over. Why are we not getting a request for the? There we go. Accept the request. So this is the vault system doing blockchain stuff. We have a new engineer that's all set to make this stuff faster. So then you can, if you have chain link stuff, you're going to lock up 50 chain. Oh, do I have, how much of that stuff do I have? I do. Okay, so maybe I only want to lock up 25. Link is used to pay Oracle fees in the chain link system. The run to receive. Oh, I get to choose how much to get back. Can I get 25 run for that? Because I might not borrow as much as I could. And then I can choose what purse, but I only have one run purse. And the collateralization percent. Ooh, I hardly even know what that is. I think it's supposed to be over 100%. Percent must be above.
It says above 0.
That's not very happy. Oh, you got to be kidding me. I can't do this because, all right. So this is the swap thing, and I can swap agoric build, say 20 of them or 5 of them for run, and I'll get 615 because the price of that is that. And then we get an offer over here, give and want, approve the offer with offer safety stuff. Okay, and then my purses will change in a few seconds, or if they haven't already. I think they did. What did I sell? Build for, right. Oh, yeah, I had 5,000 build, and now I've got less build and more run.
Cool.
So this page here is our analog of this page.
Mhm.
So this is what the world looks like after the stakeholders agree to launch the economy.
Cool. Neat. Yeah, that was interesting. Yeah, thanks for walking us through that.
You're welcome. Let's see if I had anything else queued up that was interesting.
I threw a few things on the queue if we wanted to, but
Which queue did you put them on?
the chat.
So,
Um,
was it obvious to you how naturally rholang supports object capabilities pretty much exclusively?
Yeah, so if you are not given the, so this is the reason I asked the compiler thing and also about the unguessable thing, right? So if you are able to enter in the addresses and people are using just, like a couple of, if we were using basically tallies of 1 to 3 and you were manually entering that into the lower level row calculus, then it would not seem very OCAPy to me. But if your compiler, this is why I asked the compiler thing, if your compiler is managing all that stuff for you, then it would be an OCAP language in my view. So having the language stuff not actually be something that the user itself is modifying feels like it gives an OCAP system. But if the user is manually constructing the names and is constructing things, then that kind of feels like it's not an OCAP system at that stage.
Right. You don't get to construct X. In fact, that would be forging X.
Right.
Right.
Okay. Yep. So the rholang, it's obvious that that's the case. If you're doing the low-level row calculus and you're able to construct those, and that would not seem like an OCAP system if you're just saying, "Hey, because then the user's going to be like, I'm tired of putting
Right.
in these stats and things. I'm going to do 3 of them." Yep. Okay. Makes sense to me. Cool. I did it actually. So there's a couple of things I put in the chat. So let me actually prioritize something we had. So actually, I don't. Let me just throw them out loud. One of them would be the automatically generating the Granovetter diagram stuff. The other one would be the. I'm curious what you thought of the video I sent you, and whether or not you had any thoughts or feelings about that. But maybe that's not as interesting if the other people in the call have not talked about that. And then we could also just talk about kind of OCAP and standard stuff, or the Glowlang stuff if you haven't looked at that yet. What's interesting to you?
You said Glowlang?
Yeah, I got contacted by the people who work on that recently. It's kind of
Yeah.
interesting. It's a smart contract language, also, and what it's doing is building a thing that's kind of general, but is able to eventually compile to ZK snarks and stuff like that.
Am I on the right planet here with my browser?
Yeah, so that's the docs page, and then there's also a website that's got at glowlang.org. And yeah, which is the same thing. It's just if you just go to the top level, but this is actually probably better. So I got contacted by the person who worked on this, and actually Reese had reached out to me, or Jonathan. I guess everybody else calls them Jonathan. I always just call him Reese. But anyway, so Jonathan Reese reached out to me and actually pointed out this thing, and apparently he knew the person because they're the person who worked on ADSL for Common Lisp. And we're well known in the Boston Lisp community. But anyway, this is their approach is different in that they're building a language that can cross compile to a bunch of these different things. But I guess the bigger thing that cross compiling to a bunch of different languages like the EVM and stuff like that doesn't seem as interesting to me as having a language that compiles to, I guess, what Christopher Allen's been calling the kind of scriptless script type approach, where you compile to this 32 byte thing that is just ends up acting, that you can give inputs to in the whole world of ZK zero knowledge proofs that I don't understand. So I don't know. It seemed interesting, like something you might want to look at, but arguably it is maybe a competitor to agoric. They're certainly aware of agoric stuff, but I think they're taking. I really think that it looks like they're doing a different thing than agoric, in that they're building something that is focused more on proofs and more on these kind of things it can compile down to. Anyway, maybe that's just maybe that's something for you to just take a look through. I don't actually have much experience looking through it. I just thought it was.
I wonder if I have looked through it.
Yeah.
There's one of these things where it's kind of interesting because they have a programming language that is sort of like a normal programming language, and then there's these little escape hatches where you just get to write Python. And
that's definitely not this. This one's implemented on top of gerbil scheme.
Okay, well, this other one, you just get to write Python, and the Python basically it comes up with a witness that says this problem can be solved, and here is a solution. Here's a solution to it, and then in the zero knowledge world, all that gets sent out is a proof that such a thing exists or something. It's kind of interesting, but anyway. So you get, in other words, a bunch of the computation happens off chain, and all that goes on chain is just a proof that it can be done. Or
right.
that it
Yeah.
has been done.
A few years ago at Rebooting Web of Trust, Christopher Allen said, "Mark and Christine, I want you to follow me." And we said, "Okay." And we went down to this room, and then a whole bunch of cryptographers filed into the room and just told us about a bunch of stuff that was like, so this is like, 3 years ago, that was like, felt like we were hearing about dark magic we didn't know was possible. Where it's like, oh yeah, here you can write all these programs and they compile the 32 bytes, and then you can compose them to other things and they compile the 32 bytes. And I guess now this is fairly well known, this type of thing, but this was the first time that I had kind of seen any of it exposed before. And it was kind of wild. And one of the things that I took away from that was, well, gosh, that's a much better way of doing certificate-based OCAPS, right? You don't have to encode it as data. You could encode it. You could encode your attenuation and everything like that, just as this thing that gets thrown into 32 bytes and not have to send all this data across the wire. In fact, maybe you could even actually create, one of the things I was thinking about with it, not with this specifically, but that in general, of having these kind of scriptless script type things. That's Christopher Allen's phrase. Yeah, ChiaLisp is another one of these that does that. And there are things written on top of Python. I have no idea why they did that. Why did they write it on top of Lisp? Why did they write their VM on top of Python? It's so strange. I almost did a re-implementation of it just to see on top of a Lisp, but I was so blown away. Why did you write this on top of Python?
Well, Brom
anyway,
he hacks in Python, whatever.
Okay, but anyway, it's the same type of thing. And I guess the main complaint that Christopher Allen had about this is that it wasn't typed, and he wanted to have like typey proof things. But yeah, the whole compiling down to this like 32 byte thing seems interesting. And one of the things I thought about was, it would be interesting if instead of sturdy refs, you had something like this. And I don't quite know exactly what that means, except that one of the things that I would like, it could be a proof that, for example, you're able to get something from some C list that is not exposed externally or something like that. Like, here's the things that have been thrown in this C list that's just integers, right? I have proof that I'm able to get something from that thing. And then you could also include delegation and attenuation on top of there, and might be able to create a more powerful type of sturdy ref type thing. But I don't know. This is just me thinking out loud.
Something mildly close to that. Yeah, and that's all black magic to me too. But we are connected at the hip to Zcash. So occasionally we get access to people that actually understand all that crap.
Yep.
In particular, they asked me to come to their Zcash gardening club, and so this was hosted by Nathan Wilcox, whatever, the guy, the actual brainiac. Zuko is, believe it or not, the business guy.
Is Zuko is Nathan his brother?
Yes. Yes.
Okay.
So
cool.
This was me telling them about our smart contract, but we did brainstorm a tiny bit about how you would connect the two systems together.
Okay, good. This is that's there, and obviously all the ZK Snark stuff. I mean, they're the main implementers of that in the world right now. So
have you heard of this Mina? No, probably not. Mina blockchain. this Mina blockchain, the whole blockchain is 22 kilobytes and it never gets any bigger than that.
Yeah, and I'm taking it that it takes the same kind of
Yeah, somehow they do
approach.
the zero knowledge magic and it just, I don't get it. But yeah, so you can
Yeah.
fit the whole blockchain on your phone all the time. And anyway.
Yep. No, I mean, like with the extent of the shape of the black box, I understand. It makes sense that you could do such a thing, but I
Right.
don't know what the internals of the black box are.
Yeah, and they have a smart contract language that compiles down to these circuits. It's kind of an OCAPS thing, and it compiles down to these ZK circuits things that I don't really. I sort of understand how you can the secure multi-party stuff. How you can do addition under encryption. That's about the most I understand of this stuff.
Interesting. So, okay, so that's interesting. It seems like that's a ripe area to explore in the future. So speaking of ripe areas to explore, did you have a chance to watch the video I linked you earlier?
I did, but
what do you think of it? And maybe we should actually tell the audience what the heck we're talking about. So here, I'll pull it up.
Hurlis and Earl.
Copy pasta from my chat with Dan. So yeah, this is I think they have not announced it yet, but I just put it in the chat. They're going to be announcing it shortly. It is public. They just haven't announced it yet. Okay. This is a talk.
So welcome everybody.
Stop.
Yeah, so this is my talk about propagators and the implementation I call Brainy on top of sprightly goblins. So yeah, I want to hear, what did you think, Dan, of this talk?
I definitely think spreadsheet computing is a good way to get computing into the hands of more people. Mm-hmm. And this is, a lot like, it definitely subsumes spreadsheets, right?
Mm-hmm. It has the similarities to the type of properties you see in spreadsheets, yes.
Yeah.
Yep.
But the fact that it goes all the way up to like JITs and static type analysis, all that kind of stuff, that makes me scratch my head and want to go read the papers. So I'll have to do more of that.
Yeah. Cool. Well, I think it would be fun to have a future conversation about it. I mean, the part that I think really yeah. So if you're not familiar with the propagator model, it's definitely worth reading Radul's dissertation, which I'm going to put in a link here as well.
Oh, and the other really cool thing was the bit about how self-driving cars just use these neural networks that nobody really understands, and then you can use these propagators to after the fact write an explanation of why the car did what it did. That's really wicked.
Yeah, that was Leilani's dissertation. It's yeah, so I'm actually going to link to both of those. Propagation networks possible. So this is Radul's dissertation. That's kind of about the most kind of modern version of propagators, which is the one I showed in my talk, and then also explaining. Let's see if we can find it. Yeah, so Leilani's dissertation. Here it is. So this is, and then there's this other one, which is this one's about the self-driving cars using propagators. Yeah, and I think that the other really interesting thing that is that embracing partial information. I mean, I really basically kind of crunched to get that demo together, but the showing off the part where the system is able to not only be refined as you submit more information, it's actually able to refine the information that you put in.
Yeah.
Right. Yeah. That's the fun part, I think. Yeah,
okay, so I'm going to pause here. I'm fascinated by that, but it's drifting from OCAPS. I want to go back since Bill is here against his never working on a Saturday thing. I'm curious, Bill, if anything in particular brought you here.
Me and my wife had an argument this morning, so I had to do something.
Excellent. Not excellent, but remarkable. Okay. You're not here because you wanted to talk about CapTP and stuff.
No. I am here And you know, this absolutely, this is a chosen activity at this point. I could be
Okay.
doing something else as well, right?
Yeah.
So this is a chosen activity. Let's, if you want to go through Cap TV and talk about some of that stuff, let's go.
Well, yeah, we kind of did earlier, and my
Actually, I have to leave.
Yeah.
Bill, it was nice meeting you for like a second. I hope that maybe we can meet again on one of these types of things, and I'd love to actually do one that's specifically about CapTP. But I have to leave for now. Thanks for inviting me, Dan.
Sure.
And have a good one.
Good to meet you. Bye-bye.
Nice meeting you, Christine.
I was aiming for 90 minutes, but these often go to 2 hours. But it could be useful to just talk about when's the next time we're likely to cross paths. You're still not available to work on this until you'd finish something else, right?
Well, so you probably should have come to the closed door meeting yesterday for Arching.
Oh, can we stop the recording and talk about such things?
Well, I mean, all of that's covered under an NDA, right? So,
Yes, I have executed the NDA.
right. Well, so there's still